we're going to do, my friends, is we're going to do load calculation. We're going to do generator sizing based on Cummins. You should have an icon in your desktop or somewhere that looks like this, right? Power, suite, Cummins, click. Oops, that's a report. We don't want to report. No, no, I don't want to report.
Do we have to register it?
No, no registration. Don't register. Looks like this. When you open it, it tells you, do you want to register? Not this time. You can register at any time, but go click on it. And you, when you're, everybody's here, can you give me a thumbs up when you go no, and go there? What's going on with your thumb? It's going flying up in the air, Andrew. Okay. Project. Can you see the project here? Hit project and open. Okay, we're going to go open. Okay, so do you guys have something similar to mine when you open? Hit project and open? Do you have something similar to this? You want me to repeat that? Don't register at this time. No, no, no. Hit no, and when you're here, give me a thumbs up so I can move on. Or no, if you have an option no, hit no. It doesn't matter when you. Okay, cool. Thumbs up, Chad, good. Okay, so what I want to do, guys, my friends, is I want to be using this software. Just to give you an idea before I move ahead, I want to remind you that my generator is sitting right here. Can you guys see the gen that we did in Revit is sitting right here, big fat boy. We're bringing the power from the generator into the auto transfer switch. Can you guys see that? That's how we're going to bring it. From the auto transfer switch, we're bringing it to the main panel. From the main panel, we're bringing it to the receptacle panel and the lighting panel. Cool? So these are what we're feeding from this generator. Here's how I'm going to do it. I would like you guys to put them in steps. The first thing, when the generator comes, the auto transfer switch will switch everything at the same time right now. Everything, right? So, but the way I want to organize it, the first thing I want to drop is all the loads of the lighting panel. I'm going to drop it. All my loads of my lighting panel, I'm going to drop it. Oops. Let me get my email out of the way because it keep popping and poking. Close this. Okay. So I'm going to bring my lighting panel load first. Then I'm going to bring my receptacle load second. Then I'm going to bring all my mechanical equipment load. The rest of the mechanical equipment. Can I have thumbs up, Chad? In this order: light, receptacle, then mechanical equipment. Cool? Okay, so let's go ahead and start. So let's minimize this one. Go to my okay, so let's go to my software. Chad, there's so many of them I have here. Okay, so here's my software. Here's how the software is so simple, very simple, very simple. The first thing I would like you guys to go is go project. First, make sure this is blue. Everybody can see this is highlighted as blue. And they go project and edit. Everybody can see project, edit, and edit selected project. Edit selected project. Everybody's there. Click on that one. When you go there, you have to name the project. So it's going to be commercial project. Okay. You can put any comments, headers for the report that you want. You can add anything here. Commercial project, ECD 2. What is it? This one is 2210, right? 2210. You can add anything you want here, as I said, as for your reports. These are bare minimum. Cool. Let's go to the parameters. Everybody clicked on the parameters. General, commercial project, ECDM 2210. Are we 22 or 21? No, I'm sorry. We are 2. These numbers, I still try to remember. 2110. Okay, so here's my commercial project. Everybody got there? Okay, you go, first of all, make sure this is blue. Can you see that little blue, new blue? Yep. Go to projects, edit, and the bottom one, selected project parameters. Cool? Yep. When you go there, commercial, project, and ECDM 2110. Obviously, when you are in the field, you can put your company's name. You can add this one for addresses, whatever you know, address of the company, who did the work. Let's say report headers, guys. Write your name here, Chad. I'm gonna write Chad Curdy here on the report header. Write your name in one line, and you can add other things in the other 3 lines. Cool. Can I move this the general? Next, parameters. Parameters I want you to pay attention to. So, Darren, let's start with the top one. Number of set running in parallel. Now, first you run one. If you don't have a big fat generator that can carry the load of the building, what do you do? 2. If you still can't have a size, what do you do? 3. No, you don't jump to 7. So you go in order. 3. 3 can't carry you. 4. 4 can't carry you. 5. In this project, gentlemen, we're going to be able to carry it with what? 1. Next project, you're not going to be able to carry the load with 1. So what are you going to do? Change it to 2. For the time being, we'll leave it 1. Next, minimum generator load allowances, rated capacity. Leave all these guys. The voltage depth, the voltage peak, and the frequency. These are set by the manufacturers. So this is parameters for the generator. We're going to maximum allowable frequency depth. We're going to allow the frequency to go 10% less momentarily without tripping the generator offline. So leave these as is. The same thing for the voltage, 35% dip on the voltage. Dip is not drop. Everybody knows the difference between a dip and a drop. A drop is for a long time. A dip is for a couple of seconds, a couple of minutes. Everybody understand that? The dip is measured in seconds and minutes. The drop is measured in hours, right? Okay, so leave him as is. Altitude. What's the altitude in Minneapolis? I think, are we 800 or 600 square foot? I think we are 800, so let's put 800 here. This is how high the altitude of the location of this generator. Because the higher the altitude, the less circulation of air and problem pressure is going to be. So you have to derate your, believe it or not, if you put a generator at a higher level, you have to derate that generator. You can't load it the full capacity. You have to load it less. So just be aware of that. So 800 is good enough for us. Ambient temperature is good, 77 ambient temperature, because we're going to put it inside. Sound level. Do we have a sound level? A quiet site. Let's go pick quiet site. It's a residential area, quiet site. So I picked quiet site. Allowable armature temperature rise. Leave this to the manufacturer. The bottom one, fuel. Typically, here's your option. You have propane, you have natural gas, or any fuel, or diesel. Typically, a lot of people, guys, do diesel or natural gas. We're going to do a diesel engine generator. Thumbs up, Chad? Diesel. The phases. Do you think we should do a single phase or a 3-phase for a 3-phase system? Duh, Chad. Your system is 3-phase. What do you do? 3-phase. The frequency, we're in the US, right? So we use 50 or 60. 60. Standby. Okay, this is important. It's called standby, primary or continuous. Standby, this generator is going to be only running if I have a storm that hits the transmission line and I lose power, I run it. Cool? So it's going to be running for probably maybe 100 hours a year, 200 hours a year maximum, because how often we get a lot of storms and we're in the office. Okay, that's called the standby. The prime is going to run if the Excel will call you and say, we are overloading the grid and we want you to shut down and run your building on your generator. Now you could run for a couple of days or a couple of hours here. So it runs more. Prime means it runs more, but it's still for maybe 2,000, 3,000 hours a year. Continuous, anybody can guess what continuous is? That's your 24/7. Now in the US, you cannot size a generator continuous. You really have to be military or somewhere else to run a diesel engine generator. Anybody guess why? EPA, Environmental Protection Agency, will kill you, literally. So almost all the generators that we size are standby. Okay.
What do they do for, like, if it's like the weekend? Is there parameters that are set for, like, say you lose power on a Saturday or a Sunday, so the generator has to fire up and just run when there's nobody in the building?
Yeah, if you have an auto transfer switch, they would. For data centers all the time. Yeah, they can. The generators, they don't have to be there to run.
No, but I mean, like, if there's nobody in the building, if the building's shut down, if it's not open on like the weekend, you get a big storm,
Ah,
you lose power.
well, this is all in the programming. Do you want it? Do you want the generator to, like data centers? Yes, but the building is not running and you lose power. You can program it not to run certain amount of time. It's all in the programming. Yeah, no, you don't want it. If you lost power and nobody's there, do you want your generator to come online? No. All part of your governor of the generator programming. Okay, so everybody knows the standby. We got standby. The second thing, guys, is right at the bottom, the voltages. We have 277, 480. Is this the voltage that we're using? Definitely not. Anybody can see 28, 120? Um, right here. Everybody can see it. Way at the bottom, almost at the bottom. It's RO98, 122.8 parallel. Everybody saw that? Anybody guess what this is? The voltage of the generator, right? Now, next project, you're going to come there and change it into 480, 277, or 277, 480. This is the most important. These are the parameters of your generator. Thumbs up, Chad? Okay. Hit OK before you leave. Okay, so now I know what type of generator am I sizing. What the voltage, what the parameters, what the fuel that I'm going to get. Thumbs up, Chad? Let's go size it. Gentlemen, let's go size it. Okay, when you size the generator, there are two things you have to do. Number one, you have to put your load, add your loads. Number two, you have to assign your load a step. So what the heck is a step, Chad? A step is, a step is when do you want to bring this load online? Say if you have 4 loads. Step 1, load 1. Step 2, load 2. Step 3, load 3. Step 4, load 4. What's a step? A step is we flip the switch, load 1 will come on within 10 seconds. Give it 10 seconds. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We start load 2. Another 10 seconds. We start load 3. Another 10 seconds. Load 4. Everybody understand that? We do not start them at the same time. When you size generator, guys, there are two parameters, running load and starting load. If you start all your load at the same time, your generator is going to be huge. If you start your generator in steps, your generator is going to be smaller in size, cheaper in price, of course. Everybody understand that one? So your goal is when you size a generator to start your loads, all of them, but not at once, in steps. How do you start loads in steps? Auto transfer switch 1, 2, 3, 4. Right? Put them all in auto transfer switch. That's one option. So if our auto transfer switch picks load 1, wait 10 seconds or 20 seconds typically. Auto transfer switch 2, another 20 seconds, 3, another 20 seconds, 4. Now, but how many auto transfer switch we have here? We have only one. So technically we could be on one step. That's one way. The other way, guys, is when you load your systems, as you have relays, you can control all the mechanical equipment. You can control them to pick up delay on them. You put 10 minutes delay in each one of them. That's another thing that they do. So this machine will start. The second machine have a 20 seconds delay. So wait for 20 seconds, then start. That's how they do bigger machines, delay. So since everything that we have right now, guys, is on the same auto transfer switch, so I'm going to go and put my stuff just to you know what, because the only one auto transfer switch, so all the loads are going to be switched at the same time for the most part. So here's what I'm going to do. Let's go for the load. Click on the load. I'm going to start with the first load. Can you see this bulb? Anybody can see what this type? This is light, right? Click on this. It opens the window like this for you. Okay, before you go anywhere, let's go to your load calculation. Jeff, I'm going to go steal your lighting panel load. Remember you size the lighting panel for me? The kVA. What was the kVA? Go to your load. Here's Jeff's lighting panel load right here. I'm going to go steal his lighting panel load. Okay, right in here. In kVA, total kVA. Is that the total kVA, Jeff? Where am I here? I know it has been a while since we were there. Total kVA should be that one here, right? The kVA. Everybody understand where I'm going? I'm going with the kVA. Let me see, control and zoom a little bit. Control and zoom out. Oops. Let's go back again here to load calculation. Takes a second, guys, to get them. Jeff, orient me in yours. This is yours. Volt amp, total volt amp. That's it, right? Everybody understand? 68375. The kVA. Everybody got that from your own load calculation. Don't sweat it too hard. So I'm going to take 68375. Somebody remind me of that number. So I'm going to take. Okay, let's put it here. I'm going to put it right next to me so I can adjust it because I have a memory of a chicken. Oops. Okay, what was it again that we say? All right, so let's go to the kVA. Remember, kVA 68, so it'll be 68.735. 375. Everybody knows why I put the point, because it is in what? kVA. Mistake number one. You drop that number, guys. I click on the kVA here. All right, it's a 68.37, right? 375. 68.37. It's not allowing you to do the 5. Okay, so just make it 8 then. Approximate it. 68.38. Everybody got that one? It's a kVA, so you have to divide by 1,000. Got it? Okay, what's the voltage? 2.8. What's the phase? Here's the confusion. The loads, all the loads together would be seen on a 3-phase system. The lights are single phase, but the chunk of load is coming from a 3-phase panel. It's balanced. It's supposed to be balanced, right? So we leave it as 3-phase. Everybody's okay with that? 3-phase. It's a 3-phase panel. 3-phase. Okay, what type of light? I have incandescent, discharge, and fluorescent. Now remember, the majority of your lights are what? Leave it fluorescent. I know we have a couple of things here and there. The majority of it, what? Fluorescent, leave it fluorescent. Okay, so fluorescent. And then go next. Everybody's okay with that? Go next. Where are we here? Oh, the top. Oh, I'm sorry. Let's name this one LP. Name it LP. Everybody knows what LP is? Lighting panel. Okay. And then let's go to next. When you go to next, can you guys see the power factor is rated for 0.95? That's okay. Leave it as is, given as 0.95. And running power factor is 0.95. Leave it as is. Don't mess with it. When you're done, do me a favor, hit the finish. You got load number 1 is on. Thumbs up, Chad. So all your lights are done. Let's go to the receptacle, will you, gentlemen? Receptacles. For receptacles, can you guys see that little symbol here? Everybody can see it? New miscellaneous load. Okay, cool. Everybody's there? Click on that one. Okay, what am I going to use? I have welding, general receptacle, use defined. Let's use general receptacles, because typically they are general receptacles in an office, right? That particular panel. Hit, everybody pick that one? Hit next. Okay, the first thing I'm going to name it here, way at the top, I'm going to call it RP, or whatever you guys named it, like receptacle panel. And everybody got that there? Now I'm going to go find the actual size in kW or kVA. Don't worry about kW, kVA here. So I'm going to go to my friend. Who's my friend? Jeff, can you tell me if this is 32,000 is yours? Is that it? I'm looking at the right one? Okay, it's for Jeff, the receptacle panel size that you guys size. Jeff came up with 32. If yours is different, don't worry about it. Substantially different shouldn't. But if it's different, don't worry, sweat it too hard. So I'm going to use 32. Remember, it has to be in kVA. So it's going to be 32.29. Okay? So go there here. So this is going to be 32.29. Everybody's okay with this? Now, am I single phase or 3-phase? They are receptacle, they're single phase. But the panel itself is what? 3-phase. So leave it 3-phase. That's the most confusing part. The panel's 3-phase, leave the load is going to be balanced between the 3-phase. Can I have thumbs up, Chad? We got it, gentlemen? Okay. You can write comments. One comment says Chad is a cool guy. Oops. Or anything you want to write here. So you go next. I want to remind you, there's a kW. Don't forget the kW. I have students, guys, ran it. Say, Chad, there's no size for generator. Well, if you put the 3200 kW, that's a lot of generator. So instead of 32.2, next, here's the assumption. These receptacle power factor 0.9, 0.9. If you don't know otherwise, we leave the default. Unless you know otherwise, what do? Leave it default and hit the function done. Cool, we're done. We're done with the lighting panel and the receptacle panel. Any question? So any load in these two panels have been accounted for. Cool. Hold on a second, we'll talk about steps. We're just putting the loads here. We're not running them yet. We're just adding them. Then we're gonna assign them to a step. We're gonna assign them to a step. Don't go ahead of yourself. Now we're done with lighting and receptacle. We're gonna go to the main panel. Now, can anybody remind me what's in the main panel? Thank you. Major motor equipment. If you have major motor equipment, you don't take the lump sum. You don't take it as a lump sum. You take it as one load at a time if it's major equipment. So for this, for the main panel, I could have taken the volt amp of the main panel, guys, and get rid of even the receptacle lighting because it's already included, and color it in. That will be your generator, will be that big. In order to find a right size generator, you have to go to the type of the load. Lighting panel is all one type, receptacles are one type. I'm going to go into the main panel and pick every load at a time. Okay, for this, my friend, I want you to go here to 1 second here. So get me, you see that? I want you to go to the narrative mechanical equipment, and let's start with the air handling unit. Everybody can see the air handling unit, right? Now the air handling unit, I want somebody genius to read this one for me. It says air handling unit, 15 horsepower, 2.8, 3-phase, provide a VFD as a start. Can I have thumbs up, Chad? Now we're gonna go find an air handling unit with these characters and dump it right in the system. Okay, so let's go find it. 15. So air handling unit. Here's my option. Look at my option. I have air conditioning. I have motors. Air handling unit is a motor. Why? Because they have horsepower motor. Can you guys see where it says that little baby here? New motor. I'm going to put it as a motor. Click on motor. When you bring the load, I'm going to call it air handling unit. How many of them do I have? Only one. So I have my air handling unit 1. Everybody's there? I call it air handling unit. Am I going too fast? Air handling unit. Next, what's the horsepower, Kerry? 15. Thank you, sir. 15. What's the voltage? 2.8, 3-phase, right? Everybody got that one? Now look underneath it though. Motor type. Am I running an EMA or am I running a VFD? Okay, good point. Your options are going to be either VFD or NEMAs. So if it doesn't say VFD, you're going to leave it NEMA standard design B, C, and D. Can I have thumbs up, Chad? Or if you know it's high efficiency, you click high efficiency. We don't know. So I'm going to go click a VFD. When you go VFD, it gives you two options. Conventional AC inverter or pulse width modulation. The most common now, guys, is pulse width modulation. Click on the second one. That's the way the VFD works. Pulse width modulation. We're going to come to this one later on. Done? Okay, next. Where's my next? Next is the power factor is assumed to be 0.9 and the efficiency is 90. There's nothing I can do about it. I have no information other than that. This is the default, and you hit finish. Gentlemen, you got yourself the air handling unit. Yeah, no, unless you know information about the equipment, take the default. I know you can change it, but do you have info? No. Unless you know from the manufacturer, take the default, the safest way. Can I have thumbs up, Chad? Let's go to the next load. Now, I'm going to do one load of every type. All the motors, you're going to do them the same. All your motors, you're going to do them the same. So I'm not going to do all the motors. I'm going to flip into into another load. You guys will do it on your own convenience. So I did the air handling unit as a motor. Condensing unit. I'm going to go pick the condensing. Why? Because condensing unit is different than motors. It has a condenser. Okay, condensing unit. Let's go to the condensing unit. Where's my gentleman? Here's my my condensing unit is the bottom. Now, who's my genius? I have a condensing unit 1. It's 81.6 total unit rated load amps, and it's 208 3-phase, and if used, disconnect to adjacent to the unit. Do they say anything about VFD? Fuse disconnect. So the controller is going to be an EMA. Okay? Typically, they have a VFD though. So can you guys remember the 81.6 amps and the voltage? That's where I'm going to go input there. Okay. So let's go to my system. Yep, thank you. Here's my air conditioning. This is for the condenser, air conditioning. Everybody can see that? It's not a motor. It's a special type of motor. That little snowflake. Click on that one. When you go there, there's one little problem though. It's giving it to you in what? In tons. Now, here's how we handle it. I don't even, can you guys see the running amps? So let's go, let's go put the, can you guys put 10 tons? 10 tons, and you look at the amps. Can you guys look at the amps at the bottom? Everybody can see the amps. How much amps 10 tons will give you? 52. How many amps are we looking for? So how about if we put 15? That's how I kind of manipulate it. No, 50. Not close. What did we say? Let's say 16. 16 is what am I looking at? 81? Okay, how about, what did we say? I don't think it allows you 15.5. There you go. How about 15.5? Everybody understand what I did? I manipulated a ton, the tons, guys, the tons and the kilowatts are, you have to have the multiplier. Sometimes they're 1-to-1, sometimes they're not. So the best way to manipulate it here is just put your amps or your kilowatts that you know, and look at the bottom how it converts it. So I put my amps of that, my tons, and I'm looking at 81.15. This is close enough for government work, right? Is that close enough for government work? Can I have thumbs up, Chad? We know how to do that, manipulate it. Thank you. Oh, good. CU. We have 2 CUs, so let's call it CU1. Remember that they have 2 CUs? Call it CU1. Good point. Now, do I have a VFD? I didn't say anything. Typically, they will have a VFD, by the way. But since we didn't say anything about VFD, leave it as is, ANIMA, and go next. Okay, here's your option. Across the line start. All these are your option. Letters. I just want to go to the method. Click on the method, guys. Here's your across the line start. You can use a Y delta, part winding, resistive, reactive, auto transfer, solid state. Minimum, the equipment probably will have a solid state. Pick a solid state. These are meaning electronically turning on and off electronic device. Okay, and finish. Gentlemen, you got yourself a condensing unit.
Doing the method again, you put solid state.
I put solid state. That's how we're going to start it. Typical. Okay, now I'm going to go and look at the other loads and see if I have other loads that I need to do. So I want to remind you guys, I don't have UPS. I have a UPS. I do have a UPS at one time, right? UPS. Let's go to the UPS. Okay, before I go there, let me just tell you what you guys are going to be doing, which I'm not going to do here. Here you go. Bam, bam. Okay, now I need you guys to pay attention a little bit, please. The future condensing unit. Do you guys think it's going to be the same? Yep, the same like that, exactly the same. I'm not going to do it. Boiler, gas boiler. This is peanuts. So go use it as other loads and put 500 and make sure you put it single phase. Okay, other loads. Boiler pump 1 and 2, they're motors. So how are you going to do them? Like we did the air handling unit, same way. I'm not going to do it. Recirculating pump, the same thing, guys. If you can't find 1/12 of a horsepower, what do? Get as close as you can, 1/4 or whatever. Cabinet unit heater. Let's do I have cabinet unit heaters, and I have exhaust fans exactly like motors. So I'm going to do cabinet unit heater. Let's do one cabinet unit heater. It's actually There's nothing in it. It's like a horsepower, right? It has a horsepower. So exactly like a motor. I'm going to do cabinet unit here 1, will ya? It's a quarter of a horsepower, 120. And what this day? It's across the line. Okay, so let's go use cabinet unit heater. Motor. Everybody knows why it's a motor, because it's the gas, they're burning gas. Click on the motor. I'm going to call it cabinet unit heater -1, or whatever you guys call it. The horsepower, what was the horsepower of that boy? A quarter? Okay, so it's 0.25. 0.25. Now, what's the voltage? Single phase. What's the single phase? 120. Make sure you change the voltage. It's single phase 120 because it's one load. What's the, how do I want to start that boy? It says capacitor start, leave it. Leave it as the, I have capacitor start, split phase, leave it as capacitor start. I mean, really, they're peanuts anyway. Go next. And here's your power factor, leave as is. Don't mess around with the code letters unless you know otherwise. And gentlemen, hit finish. I have a cabinet unit heater. Cool. Now, all the cabinet unit heaters therein, do them the same way. All the exhaust fans and the pumps. Can you guys, can I have your attention, guys? Exhaust fans and pumps, you're going to do them exactly like the air handling unit. One last load left. One last type of load. That was the AC. The AC file server. Okay. Any question, guys, about this? I'm not going to do the cabinet here 2, 3. You guys will do it on your own time.
For the motor, if it's, so we're not putting 3-phase.
If the motor is not a 3-phase,
Okay, so
no.
that's just one on the motor, not the system.
Yes, you're looking at one load at a time, unlike the panel. Okay, good point. Okay, the last different, everything else will be done the same way, guys. Look at the file server. Can you guys see the file server here? That's a special type of system, file server AC. This is an AC unit, right? What's the characteristics? 12, it's a 12.7 amps, and it's a 208 single phase. I'm going to go do that one, okay, because this is different. So let's go. So let's go here. Okay, so this is this is an AC. So I'm going to click on AC. What did we call again? Server AC. AC for server. What did we abbreviate it, guys, again? Server AC. I'm going to call it SAC, server AC. Now remember, guys, not Zach. Server AC. But what did we abbreviate it, though? It has an abbreviation, didn't we? AC-1. Let's do that one. AC-1. Now remember, Jeff, can I remind you guys, whatever you abbreviate it here, Kerry, my friend, whatever you abbreviate it here, it's going to also be in the mechanical equipment, the same abbreviation, please. And on Revit, whatever you guys abbreviated on Revit, when you dropped it, has to be the same abbreviation. Okay, so look at what you did. Let's just say AC1. Okay, tons. I'm looking at, first of all, change the voltage. Well, you're single phase 208. It was a single phase 208. Everybody change the voltage. Single phase 208. Now 120. It's 2 hots, not 3 hots. Okay, let's go play with the tons to get us what. So I'm going to say 2 tons. Wow, the running amps, not even 1 ton. 0.7, thank you. 0.8, 0.8. Wow. So this is a 0.8 of a ton. Good enough? 0.8, how about 0.9? Looks like 0.9. It's good enough? No, 19. What did it? Oh, 0.9, Chad. 0.9. 0.9, 12. Yeah, 0.9. Can I have 0.9, guys, tons? How do you see how I manipulated to get the 12.73 here? Okay, next. When you go next, it will tell you all this inertia, blah, blah, blah. Accept the default and hit done. Gentlemen, we're done with all the types. Now, I will remind you, you guys are going to fill all the other information. Before you go there, can I just tell you the next step? So these are all the loads. Can I have thumbs up, Chad? We know how to input the rest of the other loads in. Cool, good. Now, we're done with putting the loads. Now we're going to assign loads steps. loads to steps. Okay, steps. How many steps do I have so far? I have 1 steps. To add a step, now what is a step before we go? A step is an AC, an auto transfer switch. How many auto transfer switch do I have? 1. So let's go on the step 1, and I'm going to drop when the generator starts. I want to pick up first my lighting system. So hold and drag literally the LE and drop it at step 1, and it goes right in there. Did you guys do that? Hold and drag and bring it in step 1. Okay. Oops, I don't want to put 2 of them. Made a mistake like I did. Delete the load from here. One more time. Here's my step. Hold it and drag it and put it right into step 1. What I have told the software guys is make the lighting panel the first panel to be energized from the auto transfer switch. Cool? Now you can, okay, so now, because I only have 1 auto transfer switch, unless you want to go, your receptacle panel have some contactor ahead of it, you can't control the receptacle panel, can you? You can't. So I'm going to go also make the receptacle panel on the same step. Why? Because I have no control over it. How are you going to control the receptacle panel? Unless you have a shunt trip circuit breaker so you can control it. So I'm going to go receptacle panel, do me a favor, and the same thing, drag the receptacle panel and put it on the same step. So what I told the software guys is the lighting panel and receptacle panel are going to be on the first step. Cool? Thumbs up, Chad? Okay. Now I started my receptacles and I started my steps, my receptacle and lights, because they're big chunk of panels. Now the mechanical equipment, I do have control over them, Darren, my friend. I can send a signal to the controller of the air handling unit and delay the start of the air handling unit for 10 seconds. So I'm going to go start another step. So I'm going to go, can you guys see that little step here? That little thing, deal? Hit that one. I have 1 step. I have 2 steps. I drop 2 steps. Okay, you can drop as many as you want. Drop 2, will you? Hit this one twice. You drop 2. Made more than 2, don't worry. We delete them. Cool? You guys have 2? Okay, I'm going to go pick my air handling unit. Well, I actually want to go CU1. Oops. Okay, so by the way, you can double click on any one of these and edit them at any time. If you say made a mistake, double click here, you can edit them. I want to go and remember AC1, that one, the server, Jeff, that's important because that was the server AC. My data is going to boil. So I want to bring this, I'm going to actually put it, you can, but I want to go put it on step 2 though. I'm going to put it in step 2, and the step is 20 seconds. 10 to 20 seconds. So I put my server in step 2. This means the auto transfer switch will send a signal to that server, say, hold your horses 10 seconds until the lights and the receptacles come to speed. Can I have thumbs up, Chad? Good. All right, next. I'm going to go, then you start picking. Which load do you want to start next? Okay. People like, I want to go put my, my air handling unit on step number 3. Here's my step number 3 air handling unit. So my air handling unit now up and running, cooking, cool. And then what else left? I'm going to go make one more step, step 5, and put my chiller, cooling. Is that the chiller that I had? My air handling unit. No, I did my air handling unit. Okay, is that my my cooling? CU1, yeah, thank you. CU1. I'm going to grab that CU1 and drop it on step number 4. Meaning, I want at step number 4, take 20 minutes, add that 20 seconds. I want this one to start next. How do you achieve this? 2 ways. Auto transfer switches, which we don't, we only have 1, or you interface the controller of the condensing unit with the controller of the auto transfer switch. So when it starts, it sends the signal, start a timer basically. It start timing, wait, bam. Can I have thumbs up, Chad? You got it. But why do you think I do it in mechanical equipment, not in the lighting? Because mechanical equipment have controllers. they already have controllers. I can interface a timer and make it control the equipment, just delay the start. We're talking about, guys, maximum. Everything will be up and running within 2-3 minutes. The delay is not hours. The delay is just seconds. 10 seconds to allow the motor to get the poop, the first push on that thing. Does it hurt? I get excited. The first hit, right? The first hit that's going to hit the motor, you want a motor to be able to handle it. You know, if all of you guys, imagine all of you came and pushed Chad at the same time, you probably would break my neck. If one of you at a time push me and then I start pushing me at one time, and then the other one come and push, my chances of handling it is better. I'm not going to handle it, but my chance of handling is better. That's called the air rush. You want the air rush, reduce the air rush on the motor. Cool. What else left? So the rest of them, here's what I would like you guys to do. The rest of them, assign steps for these loads and just assign and drop the loads, 1 or 2 loads in one step. And a step for you will be a timer that's going to control the fixtures and make it run, wait for 10 seconds before it starts. Can I have thumbs up, Chad? We understand that one? Okay, because of the time and because the rest of you guys are going to do it, I'm going to go now. You guys are going to go fill and add more steps and add more loads, right? I'm going to go. We still have one load. We didn't assign it, right? What was it? That one, that baby? Okay. Cabinet unit heater. You know what? I'm going to go through the cabinet unit heater on my air handling unit for the heck of it. Where's my air handling unit? Right here. I'm going to throw it in step number 3. Cool? I just throw it on step number 3. It's a tiny little baby anyway. It's not going to make a whole lot of difference.
You only want 2 loads per step?
Let's do it this way. Yes. Let's do it this way. Yep. No more than 2 loads per step. Let's do it this way. Meaning we'll have one timer to control 2 loads. Okay? Did we guys get all these? Did they account for all my loads? Here's lighting panel, receptacle. All my loads have been accounted. Before you start running, make sure all your loads have been accounted for. Meaning they have been inserted in at least one step. Thumbs up, Chad. Let's go calculate, gentlemen. Now, your size is going to be different because you need to add yet. But let's go calculate. Calculate is as easy. Do you see that little here sizing project? Everybody can see that? Hit that one. Gentlemen, we're sizing a generator for you. Here's the size of a generator, Jeff, that we came up with. We came up with 150 kW generator. Everybody can see that? The most important thing, it's 150 kW generator. Can you guys see that? The yellow one? Okay? 150 kW generator. That's it. So that's basically the size of a generator. All the information that you see, that chunk of info here, is coming from the default. The most important thing is the site rated standby kW is what? 150. What's the power factor for these? The running power factor, 90%. Okay. So that's, can you guys see the information about the generator set requirement? 60 hertz, standby. Here's the voltage. Here's the phase. It's diesel. And all the other requirement, 800 altitude. Remember that altitude that we put 800 at the beginning? Okay, next. Can you guys hit this tab here? This is the running load. It will tell you all the loads that's running out of this generator. I have 138.4 kW running, and alternator kW, power factor 0.92, and all this information that you need. Maximum step kW. Remember this, the maximum step that you need to start is actually 97. Remember how we step them? The last thing is generator set configuration. Okay? Alternator CUCD3G. Now go buy it. Here's the alternator that you need from Cummins. B code. Voltage range. Here's the voltage range that this baby can work on. Number of leads. This is information related to the generator set configuration, the alternator. So that information will help Cummins give you the right generator. What I did in the past, guys, I am not an expert in generator sizing. You do the calculation, then you send it to somebody from Cummins and say, here's what I think you could, can you guys look it over? Because you're the expert, gen expert. And most 99% of the time, they approve what you did and they give you your generator after you pay an arm and leg. Cool? This is all the information. Now, how do you, 2 things. When you're here, number 1, you guys can, how do you print? When you're here, can you guys see where it says report at the top here? Do you see print? You can print all available or the steps and recommendation. There are two reports coming out of this software. One report about information about the generator, diesel engine gen, and another about the load that you inserted. One gen, one load. Okay, I don't want to print them, so I'm going to go preview. Can you guys see preview? The same thing. What do you want to preview? I want to preview the recommended generator set. Click on that one. Here's the report that you get. Here's the gen size is 150. Can you guys see that here? 150. And all the information about your generator, diesel engine generator that you did are right here. You hit print, you print it for your Uncle Chad, or you save it as a PDF file. You're going to save it in your, so if I hit save right now, I'm going to save that baby as a PDF file. Recommended, maybe you have to print it as a PDF file. Does it save as PDF file? Does it save there? Okay, so you have to print it. You can print it as a PDF file and save it on the network. Cool? Okay, now this is report 1. Close it. Can you see the X here? Close it. Let's go to report number 2. Report. I want to go to report number 2 as recommended steps and loads. You can see the stuff that we inserted here. Here's step 1. Jeff, you see step 1 here. We brought the lighting panel and the receptacle panel. Here's the running load for the lighting panel, the KW, the KVA, the power factor, the amps, the alternating KW on step 1, step 2, step 3, step 4, and for you guys, it will be more steps. Thumbs up, Chad. Now, close that one right here. I want to go back to my project, Chad, because I made a mistake. Do you see that little icon here? Right here, click here, you're back at your generator. One more time, so you can add, delete, modify. Made a mistake, I added step here. I added one more step, made a mistake. You click on this one, what do? Delete the step. Right click on any of these, you can delete it. Duplicate, I have 2 lighting panels. So look at this, I have a lighting panel, 2 of them. Can you guys see where it says new, where it says copy? Everybody can see copy. I can copy it. And did it create a copy for me? And I can paste it. Okay, I created an identical copy of the lighting panel. So what do? Click on it here and go name it. Don't do that. LP-2, and you got yourself an identical to LP1. Made a mistake, no problem. Click on it, right click, and what do? Bam, delete it. Okay, so if you have 3 exhaust fans the same size, oh, by the way, say if you have 3 exhaust fans the same size, here's what you can do. You can go here, and they used to allow you to number of loads. Well, I lied to you. I thought, I don't know, maybe there's certain loads allow you to put the number, so you can, if you're 3 of them, you just put 3 and it adds it as a 3. Let me see here. Edit load. No. Okay. So if they're all the same, what do? You design one of them, copy them 4 times, rename them. Done. Gentlemen, can I have thumbs up, chat, for what you're going to be doing? Okay. Do you want to print? If you want to print from here, you put yourself on the project right here, project, and then report. And here's your 2 reports. I don't have recommended size yet because I changed. If I run this one here, it's running. Here's my recommended size. Go back here. I believe it should allow me to print both of them. Project, report. Okay, recommended, step by step, all available. Yeah. In order to do the recommended size, you have to be here, guys. To print both the reports, you have to be in this step. Calculation, report. Here's the reports that you need. 2 reports. You can print them right from here. What I would do at the end, guys, print. I would say, where am I, Chad, here? Print, reports, print, all available, which is the 2 reports. Can I have thumbs up? Is this enough to get your juice up and running? When you are done, what you need to do with this number when you come up with it, guys, you're going to go put it on your Revit and size the feeders based on this number. And how do you size the feeder based on this number? This is KW divided by 0.8. It'll get you KVA. Find the amps, multiply the amps by 1.25, and size your overconduction device and conductors. So it might be smaller than the service, which is okay. Okay? Is that enough to get your juice up and running? Cool. This is due on Friday of next week. Friday is Thanksgiving, so that will be Monday of next week.
Monday of the following week.
Well, I mean Thanksgiving holiday. Yeah, we're not here. So it's going to be due on next week. Monday of next week. Monday of the week after, actually, not next week. Okay. On Friday, what I want you guys to do Friday is low voltage E7 and E7.1. The riser low voltage and the power low voltage. But since you guys are ahead, this will get you something to chew on, right? Is that good? Can I have thumbs up, chat? Tell me that this is enough to get our juice up and running. Okay. Thank you. Before you leave, save. Before you leave it, guys, save. Go save it. Make sure you put it in your project. Before you leave it, please go to your project and make sure you save it. Go to, if it's in your computer, go to your network. I'm going to put it in my team folder, commercial project under generator size is gen size, and it's called commercial project, and save it. Could you please? Commercial project have been saved, and then exit if you wish. Thank you.